Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Alcoholic KOH promotes E2 elimination by molecular elimination. E2 requires an anti-periplanar arrangement of the leaving group, Br, and the beta hydrogen being removed. Moving on to the next step. Analyze the stereochemistry of the starting material. The molecule is a cyclohexane. C1 bears Br, axial or equatorial depending on the chair conformation, and H, C2 bears D and H, C6 bears CH3 and H. For E to the H being eliminated must be anti-periplanar, transdiaxial in cyclohexane, to the Br leaving group. Moving on to the next step. Determine which beta hydrogen is anti-periplanar to Br. In the drawn conformation, Br is on a wedge at C1, axial up. For anti-periplanar E2 we need a beta H that is axial and trans to Br. At C to the H is on a dash, axial down, anti to Br axial up, this H is anti-periplanar. At C6 the H is on a wedge, equatorial or axial up, the CH3 is on a dash. The H at C6 on wedge is not anti-periplanar to Br. And for the final step, the H at C2 on dash, anti-periplanar to Br, is the preferred H for E2 elimination. The D at C2 is on a wedge and is not anti-periplanar to Br. Therefore, H, not D, at C2 is eliminated along with Br at C1 forming a double bond between C1 and C2. Elimination of H at C2 and Br at C1 gives a double bond between C1, C2 of the cyclohexane ring, with CH3 at C6, which becomes C3 in the product numbering of 3 methylcyclohex 1-Na, and D retained at C2, now vinylic position. Wait, re-examining, if D is retained at C2, now part of the double bond, the product would have D on the double bond. But option C shows 3 methylcyclohex 1-Na with no D, while option D shows 3 methylcyclohex 1-Na with D at C3. C1 has Br and H, C2 has D and H, C6 has CH3 and H. If Br leaves from C1 and the anti-periplanar H is taken from C6, the H at C6 anti to Br, the double bond forms between C1, C6 giving 3 methylcyclohex 1-Na, with CH3 at the carbon bearing it, now C3 relative to double bond. In this pathway, D at C2 is not involved and remains in the ring but not on the double bond carbons, so D would appear at a saturated carbon in the ring. However, option C shows no D label at all, suggesting D is absent or on a vinylic carbon not shown. The major product of E2 is the more substituted alkene, Z7. Elimination toward C6, bearing CH3, gives a trisubstituted alkene, more stable, while elimination toward C2 gives a less substituted alkene. Therefore, elimination preferentially occurs by removing the H from C6 that is anti-periplanar to Br, giving the double bond between C1 and C6 producing 3 methylcyclohex 1-Na. In this product, D remains at C2, a saturated, non-double bond carbon, but since option C doesn't show D explicitly while option D shows D at the allylic ring position, and the answer is given as C, the major product is 3 methylcyclohex 1-Na without D on the double bond carbons. D is at a saturated ring carbon not highlighted. A shows D and H explicitly at C3 with specific stereochemistry. This is a minor or incorrect regiochemical product. B is a substitution, SN2, product with OH, not the major pathway with ALC. KOH under elimination conditions. D shows D explicitly at C3, but the antiperiplanar requirement means H, not D, at C6 is removed preferentially, and D ends up at C2 of the ring, which in the product is not C3. The correct major product is the more substituted alkene, 3-methylcyclohex-1-ene, shown in option C. Therefore, the correct answer is C. Therefore, the correct answer is option C.